Hi, this is Charles C. McGowan with the SolREI Company. This is Elegant Reasonisms Part 2. It is an introduction to mode shifting. This presentation in general is an introduction to the topic of mode shifting. Mode shifting is the capability and capacity to recognize how and why patterns in one encapsulated interpretive model shift EIM to EIM. And kind of why you can't see, for example, M5 from inside M1. You have to back up and back away from both of them in order to see them relative to one another and in juxtaposition relative to paradigms of interest or of nature. And even then, you need to understand the relationship that encapsulation and Langer epistemology errors have to that whole topic, and that's part of what the process and the epistemology is all about. As a consequence of that, the only way to really see all of this and to illuminate and illustrate these various issues is through the tools and processes employed by Elegant Reasonism. Our standard notice for these presentations is that they are hyperlinked back to the company's website. The best way to see this and experience this presentation is to download the PDF file from the user library under info on solrei.co, and then register if you haven't already, then to log in to the website and then bring the PDF file up and look at it. That way, when you click any of the blue highlighted hyperlinks, they will resolve to their respective pages back into the website, and you can review the greater detail as appropriate. So the abstract then for this presentation is that we want to have an introductory conversation about mode shifting, and in order to do that, we really need to understand that there are two different kinds of investigations. One type of investigation is that we have some area of interest that we want to mode shift what it is we think we know about that into alignment with the unified universe, in which case we have to use, under Elegant Reasonism rules, some model that closes to unification. And right now, the only model that's available that does do that is the emergence model. And we most often use M5 for that. For reasons that we'll get into on another time. And so that's one type of investigation. The other type of investigation is coming up with a net new EIM that is fully compliant and closes to unification, in which case it would be enumerated some number beyond M7. But that's a different kind of an investigation. And so because this is an introduction to the concept of mode shifting, what we're going to do is just take the basic core constructs in M1 and mode shift them over to M5 for the purposes of illuminating and illustrating the kinds of thinking and discussions that you have to have in order to get through the generalized process flow and the decision checkpoint flowchart, all of which we will get into in a few minutes here. You may have seen the problem challenge path framework that we use in other videos. I'm going to skip down to the rationale here because it's different in this presentation than it might be in the other presentations. And it's motivated by that first bullet there. What happened when the USPTO published Elegant Reasonism on the 26th of November in 2020 is that they basically pulled the trigger on the starting gun, and there's everybody now wants to be able to mode shift what it is they think they know in their area of specialty over into alignment with the unified universe, and everybody's trying to figure out how to go do that, and they're trying to figure out, if you're in a business, what am I exposed, what are the exposures, who's doing that, and what the issues are, etc. And so we want to make sure that we are all critically, situationally aware in our thinking, and that we can discern the pattern shifts, and that they will be dynamically reconciled through mode shifting so that we can then leverage those insights back to our business planning, our systemic value chains and supply chains, and what systemic insight integration do we have to have in order to accomplish all of that? And so that's kind of the motivating factor here. So when we start talking about mode shifting, we're probably going to be doing that in context of an investigation. So there's some area of interest, there are a set of paradigms of interest or of nature that are being investigated. But for the purposes of this particular presentation, we are going to be using the actual core constructs of M1 and M5 in order to illustrate and illuminate the concept of mode shifting. And that's probably not what you're going to be doing when you're doing an investigation. You're probably going to be looking at other factors that or other parameters or whatever your paradigms of interest are, rather than the core constructs of an EIM. And so I just want to make that clear going forward. And so in that context, this presentation is not a systems review, and it does not mode shift M1 in its entirety. There's a vast array of things that need to be discussed in order to accomplish a fully complete treatise on M1, and that's well beyond the scope of this presentation. We are simply trying to provide an introductory set of charts to this, and even that is long. So this presentation acts as fodder for discussion to assist people to understand effectiveness metric relative to that decision checkpoint flowchart. Make sure that they just have the basic mechanics down. Again, we don't mode shift 100% of all aspects concerning either one of the EIMs. Rather, it just focuses on those core constructs, the basis, and the basics of those models in an attempt to show you guys how all this stuff works and comes together. So the chart 6, the general structure of this presentation is going to try and follow the generalized process flow. So we'll put charts like this one up to delineate the different areas of the process and the flow, and in order to help keep things consistent. So on the process decision checkpoint flowchart, the objective here is to go from the upper left to the lower right. We've talked about this on other presentations, so we're not going to do that here. I do just want to quickly mention that, the two issues that we talked about just a minute ago, of abstractions and Langer epistemology errors, those are the kind of the gating factors in moving across this chart left to right. And our focus in this presentation is mode shifting. And so we want to make sure that we can do that effectively. And we do that by populating the translation matrices. And we need to know whether or not we're doing that effectively. And so we're in this loop here in the middle. Can we do this effectively? Probably in the beginning, no. And you go down through here and until you think you got that done right, then you go back up and figure out whether you've done it effectively or not. So we're in that middle loop there with the objective of trying to get over to the lower right corner of this chart. So the framework of elegant reasonism is basically three phases. You have to recognize the problem, you have to illuminate it, the issues, and then you have to do some analytics on all of that in order to develop a treatise that is aligned with the unified universe. Gating factor, going back to that decision checkpoint flowchart, is the Langer epistemology errors. And I just want to pause for a minute because there's an implication in all of this that's not really superficially obvious or intuitively obvious even. And it has to do with the highly systemic nature of abstractions and the lower order detail underneath them relative to Langer epistemology errors. If we make the mistake that some abstraction is actual reality, and that because of the abstraction and the integration of that abstraction into a higher ordered construct that we may then use in describing some set of circumstances or a scenario in an investigation or an experiment or even in daily life, then we replicate that error up into the higher ordered thinking that goes along with that set of circumstances. And that's what's ensnared us for the last several thousand years. We have to be keenly aware of those things and their systemic nature as they flow up through the framework. And that's why on that decision checkpoint flow chart, we get into loops and stuff, and it's more of a process than it is a linear kind of progression. And you have to loop a lot, and you have to go back and look at that abstraction inventory at lower and lower and lower levels in order to make sure that you're not making Langer epistemology errors anywhere in your set of paradigms of interest or of nature, or the circumstances or the scenario that you're trying to investigate. So this is the generalized process flow of elegant reasonism. We've talked about it in other videos. We're not going to go into it in detail here. Just wanted to put the chart up there. You can hit pause on the video and look this over and really kind of go through it to understand it. But basically we go from chaos and scale dependent concepts and constructs on the left. We recognize what the problem is. We go through our use a standards based approach, but we and very often you're going to have to go back and review history, and you want to make sure that you're looking at the original author and the traditional epistemologies, and we want to start thinking through those. And we want to make sure that we identify Langer epistemology errors. We want to start looking at the realm of C's, making sure that we have congruence and things are cogent and that they're concise and etc. So then, and we flow, and we want to go to the illumination, and we want to get over into the analytics and the analysis of all that, with the final objective of having an ordered, scale independent, and fully coupled, unified treatise that articulates the results of our investigation. In this particular case, we are mode shifting the basic core constructs of M1 and M5 to understand how to do the mechanics of mode shifting. So that's our objective with this one. Okay, so chart 10, we're going to get into the recognition phase of elegant reasonism on this particular presentation. So for our historical review, and just because we are working with the core constructs of M1, the bodies of work that we're going to look at and talk about briefly are that of Albert Einstein, Suzanne K. Langer, and Dr. Lev B. Okun. And a more comprehensive list that links back into a broader set of historical papers and research articles and data and whatnot is on our acknowledgments page. So if you're a registered user, you can just simply click that and it will show you that inventory of people and materials and go through that at your leisure. When we get into our abstraction inventory, in order to enable mode shifting, there's one key takeaway that's not superficially obvious in all of this. And historically and maybe traditionally, we approach science and we think, oh, well, if we just tweak this one little thing, maybe all the puzzle pieces will fit together and we'll finally have all the answer. The problem with that approach is the systemic nature of core constructs up through every other higher ordered idea. And for that reason, elegant reasonism rules state that we can enumerate an EIM and then we must iterate it. And that once we declare all the facets of a given EIM, we can't change any of those exactly for these systemic reasons. We can iterate it, and then we can actually rebuild a translation matrices with the different iterations of the different models, but we really don't, we try not to tweak a given iteration, because that's changing, that's moving the goalposts to fit the results. And we really want to try and understand, in this case, the nuances of interpretation relative to the specific encapsulation in question. And so those issues are not obvious in the standard approaches to investigations. And so when we go through and we look at our abstractions, the way we define those abstractions and employ them need to be really quantified and codified relative to the specific enumeration and iteration instance. and that's what we mean when we go through an abstraction inventory. So you can go through all these different things, hit pause and look at these things and compare them one against the other and consider these different concepts. And once if you go look all this stuff up, you'll begin to see how they relate and correlate EIM to EIM. Probably the ones most people want to look at are, well, I don't understand speed of light and what that has to do with anything. But once we've identified the abstraction inventory relative to those issues that we, at this point in the process, do or do not understand, or we think we understand them solidly, but they're not mode shifted, we just want to make sure that we're capturing all of that lower order detail as much as we possibly can. And I will tell you too that one of the reasons that decision checkpoint flowchart loops through these different process steps is exactly for the reason that we almost always never capture every factor of every instance of every abstraction. We almost always discover new things that we didn't think about, and then we have to loop back through everything and make sure that we've quantified and codified our inventory. So it's a recursive kind of a process. Don't think of it in terms of being a linear thing. We often have to loop through these things many, many times to make sure that we are considering everything, because as I said, the more you dig into the bullet points we've put on this chart, the more you dig into that and understand how those things change and what the interrelationships of them are, the more you will appreciate the importance of the abstraction inventory. One quick point about M2 is that it represents Einstein's original views. M1 really does not. M1 is a derivative of M2. And you may have noticed on the previous chart that that C, when we mode shift that from M1 to M5, that C gets mode shifted assigned to severance, not so much the speed of light, although severance produces photons at that speed. So it's still the same number, but why it means that number is different, and that's important. And so when we realize that C now in M5 represents severance, we read this point that Einstein made in 1948 to Lincoln Barnett very, very differently. And we also realize that from the early 1900s that rapidity was the governing thing for velocity, and that definition of m0 over the square root of 1 minus v squared c squared there in this image really is rapidity squared. And so when we realize the mode shifted insight of this, it becomes rest mass over the square root of 1 minus rapidity squared, and rapidity squared properly read then is velocity over severance. And so we have an incredibly different set of insights that come out of this when we mode shift these concepts. When we consider Suzanne Langer in all of this, and I would encourage people to register on our website and then click this hyperlink here to understand, and you can actually read the book from 1948 that actually details the philosophy behind all of this, and get a great deal more insight about Suzanne Langer. She was just an incredible person, had incredible, insightful interpretation of symbology and epistemology. And it's so much so that everybody pretty much blew by page 77 in Philosophy of a New Key, or In a New Key. I can count on two hands how many people kind of got that message when it was written back from the 40s through the 60s, and tried to say something about it, but everybody ignored them. And so we named Langer epistemology errors after her. And when we couple that with advanced concepts like the representational state transfer architecture the REST architecture from information sciences, we then start to see the relationships between the emergence model and higher ordered ideas like art appreciation or economics. And these insights fundamentally define encapsulation boundaries, and the ability then to perceive the unified universe demands that we start asking a whole new set of questions that we never asked before relative to mode shifting and the analytic stack of the translation matrices and process and the standards that we use and the questions that we look at when we look at them. And once you understand elegant reasonism and you can wield it with some degree of effectiveness, you will then see a whole different set of issues and insights that were not visible when you looked at those same things in the past. And when you realize that we can now mode shift 100% of all of the experiments that we've ever conducted anywhere through this process and see that information in mode shifted over into alignment with the unified universe, it's just powerful beyond measure. And we can trace it all back to the insights of Suzanne Langer. So in our investigation here, we're talking about paradigms of interest or of nature, and that's what POI/N stands for. And in this particular case, we want to talk about basis and forces in context of unification and between M1 and M5. And in order to do that, we have to understand a lot about the systemic nature of these different abstractions, their relatedness, and how that relatedness flows back up through the interpretive model or the EIMs that are represented here. The traditional failure points to recognize unification is the inability to employ a common geometric basis point. Valid geometry requires geometric basis point to be employed. M1 really does not do that for all real objects in any given frame. And I can say that because space-time in M1 must be considered one of those real objects, because everything is considered to be some manifold of space-time created by energy, and that results in a mass. And so the deeper relationships underneath that are why we get into some of the theoretical discussions of multiverses and the that are really a function of the inability to wield a geometric basis point common to every real object in the same frame. And that same issue is fundamentally why we have also been unable to fully couple all the reference frames. That is, to use or to describe the fundamental forces of nature relative to one another, because some of those forces are phenomena, they're not properties. And that's a philosophical taxonomical, that's a word. When we get into the taxonomy of properties, phenomena, and relative to abstractions and the constructs within them, we have to parse all of our language very, very carefully in our abstraction inventory and as we go through the decision checkpoint flowchart to make sure that we are not making Langer epistemology errors, and we can represent all of the forces in alignment with the unified universe, which we can do in M5, because force all force is the work instantiated by the intrinsic action of dynamic kinetic architectures of mass, configured by the fundamental entanglement function limited by severance, derived from the intrinsic nature of MBPs. There was a long systems review that generated that. We didn't just sit down and write that statement out. We had to reverse engineer that from what we were looking at through an almost 20-year systems review. But when we define it in that way, almost instantaneously, all reference frames become fully coupled, because now we can suddenly describe all the fundamental forces relative to one another. But when we do that, we come up, consistent with what Suzanne Langer said, we have a whole new world of new questions that we need to ask. And some of those questions, the 800-pound gorilla in the room then becomes, what is it that those architectures actually look like? And we don't know the answer to that yet. So we're working on that. We have proposed to the National Science Foundation that a system be developed to poke into all of that and explore all of that, and it's a big issue. It's probably an order of magnitude larger than the largest computer being currently deployed. That's a different story for a different day. But the point is, we're on it. We're poking at those guys to help us come up with that. If we list the reference frames as one of the paradigms of interest or of nature that we want to mode shift across the M1 to M5, it's a great example of something that superficially looks straightforward and simple, but is anything but that. When the systems review that we did started digging into this, we realized that inertial frames are used most often in M1 when they start talking about astronomical things or cosmological things, because the intent and motive is to create a basis of commonality between a given set of real objects that you want to describe. And in order to do that, you have to describe the different moments of inertia when you cannot establish geometric basis. We also need to get into the distinctions between M1 and M2, and to really do that requires digging into the article, The Concept of Mass, that Dr. Lev Okun wrote and is linked from this presentation back from our website. But the distinctions between M1 and M2 is what Einstein actually believed. The modern incarnation of that, of variant mass, that modern science is using today in status quo thinking, really came from Wolfgang Pauli. All of that aside, those issues are all well beyond the scope of this presentation. I'm just trying to articulate the depth of things that you have to get into in order to really ferret out all the detail that's necessary in order to effectively mode shift something, even as maybe simple as what constitutes a reference frame between the two models. The event frame and the local frame had to be created in order to accommodate the requirements of unification and the emergence model. The event frame is the frame that is describing all interaction between real systems. It is isotropic. It is scale invariant. Another interesting paradigm of interest or of nature is the concept of velocity. And mode shifting that between M1 and M5 is an interesting exercise, but it is another example of something that is really more complex once you start digging into it. On the M1 side, we have the two areas, Newtonian and relativistic kinds of thought and the various rule sets. And when we start going through the process, the elegant reasonism process, and we inventory our various abstractions, we do the historical reviews, we look at the Michelson-Morley experiment, we look at various interferometer experiments, we look at synchrotron radiation, we look at all the various historical reviews, we find words like constancy and consistency. And then when we mode shift those over to M5, we find that constancy and consistency is really a function of severance, which is a derivation of the same intrinsic nature of MBPs, and that it is a system failure that produces those constant velocities. And if everything that we employ and every experimental device that we may ever contrive on Earth is comprised of things that use electrons, they're all the same. And when the system that is the electron can only produce photons at that one speed, that's what you're going to see. The allegory or allegorical kind of reference that I tend to use is that of a gun. This is more true of a modern weapon than it is an ancient one, just because of the precision of the materials used. But the point here is that if you take a modern weapon and you take 1,000 rounds of ammunition and you fire a bullet through a chronometer that will track its velocity, as it's exiting the muzzle and then 10 yards out and 5 yards out, you'll see that all 1,000 rounds are pretty close to the same speed. And that the point here is that bullet travels the speed that it does because of the system that produced it, not because of some externally imposed rule set. It's too simplistic to say, well, it's just nothing can go faster than the speed of light. Okay, we know that interferometers measure that speed, but we really don't know if anything can go faster than the speed of light. We have this rule that says you can't. Neutrinos make us scratch our heads quite often, and then we get into things like the inflationary theory and etc. And so on the one side, we have empirically derived data from experiments. We understand that empiricism is fundamentally tied to our human physiology for all the reasons that Suzanne Langer has produced her body of work. When we realize Langer epistemology errors and the abstractions that we have employed in terms of measurements, so this is an interesting area too for the concept of metrics and quality metric, is when the experiments are logically correct, they're conducted in a logically correct manner, they're immersed in a logically correct EIM, and the logical correctness of everything is just so, it's going to produce logically correct results. And M1 in that regard, if you look at the Michelson-Morley experiment, for example, it's logically correct. It makes sense in terms of how they defined those systems and those parameters, and in Einstein's 1905 and 1916 papers, in terms of those concepts and the logical correctness of that thinking, it's logically correct. But that has absolutely nothing necessarily to do with the underlying physical systems. It only means that the physical systems that are underpinning all that support the logical view that we have. So the results, the empirical results, say more about the logical correctness than they do the physical system underneath it. That's a complicated subject all by itself, but if we use our gun analogy or metaphor, we can then flip our logic and say, okay, is there another way to consider this and those results such that we get the same results? And we would argue that we do, that the fundamental entanglement function limited by severance is the reason that those experiments produce photons at the consistency that they do. It conforms to the realm of C's. And when we mode shift the constant term C from the speed of light to severance and assign the value C to severance, we suddenly find that we have consistency in synchrotron radiation is just electromagnetic radiation, and that the magnetic fields that are controlling the electrons are producing centripetal force that produce the electrons at the same speed that everything else is measured at. We suddenly find out that the architectures of mass, that photons traveling through a gravitational field are affected as a function of the frequency arm of the architecture that is the photon. We mode shift concepts like rapidity so that V over C becomes velocity over severance, not velocity over the speed of light. And we find that that curve that we typically associate with the speed of light, to say nothing can exceed the speed of light, to say, well, nothing can exceed severance. And the reason it can't exceed severance is because severance is the failure mode of the architecture. The architecture comes apart. And that's a statement of interaction with other architectures as different than it is for a cosmological velocity. And that's why Edwin Hubble and his data set has measured what he measured with red shifts and blue shifts. And, we talk about red shifts so much that we forget that there's also a blue shift. But they're the same. And so on the left-hand side, if we back up from this discussion and this mode shift thing, we can say, okay, we have all that consistency in our experiments and our blah, blah, blah for the last 120 years. But does that close to unification? The answer is no, it doesn't. On the right-hand side, we have another potentially logically correct, and it still needs to go through mode shifting for all of those experiments. I mean, we only have two hands. We can do a few of them, but we can't do all of them. But we've done enough of them to know that we think this is the correct way. But does the M5 way close to unification? The answer to that question is absolutely it does. And so which of the two ways do you think is more correct? The one that closes to unification or the one that doesn't? And so, this is a great example of paradigms of interest that are interesting to mode shift across the body of historical work that's been done, as well as the new framework that's coming up. And also, and in terms of, if you back up from this and say, well, is the emergence model the best model? I mean, is there maybe another model that closes to unification better than the emergence model? I don't know. I haven't been able to figure one out, but if you guys can do that and figure one out, go for it. But you can use this discussion as fodder for that other investigation. And so there's a lot of thought, and this is just an example of one paradigm of interest. And what I would argue is that you can take not just this one argument, there's one paradigm of interest or of nature, but you then have to consider holistically all of the paradigms of interest and of nature, and all of the experiments, and all of the restful linkages and evidence chains that the emergence model then creates. And holistically, the emergence model closes to unification and fits all those other pieces. M1 doesn't come close. We have lots of evidence over the last, couple hundred years, 1,000 years, for being able to think of experiments in terms of Newtonian or relativistic approaches, but they don't close to unification. And the question then is, why not? The answer is, the core constructs preclude it. So anyway, this is just another example of a paradigm of interest, but it's, the full discussion of this is beyond the scope of this presentation. Hopefully we've put a few of the areas of interest in that here to get you to think and to see how the mode shifting is enabled across the translation matrices. And if you think about this down through the analytics stack and the logic calculus and the evidence chains that would link down through that analytic stack, through every one of those layers, the more you look at it, the more you will come to understand that the fundamental entanglement function limited by severance is the reason C gets mode shifted to severance. Another interesting paradigm of interest is the medium. And historically, the medium of the universe has been referred to as the luminiferous ether. It was defined then, a long time ago, as the perfectly viscous fluid in which everything real resided. And the planets and the stars, they all moved through this thing, and light transmitted this stuff, or through that stuff. The modern era then defined the medium as a four-dimensional space-time. The emergence model holds it as dimensionless nothing. And that's an interesting thing, especially when we start talking about enabling mode shifting. I want to back up for a minute and remind everybody about one of the rules in elegant reasonism is that you can, once you declare a theoretical EIM, an encapsulated interpretive model of the universe, it cannot be changed. It can be iterated, but it cannot be changed. And so the point here is that we often say, well, there's nothing there, or there's nothing in this frame, or that this is space. Even in interstellar space, there's something in every cubic meter. There may be one atom or one subatomic particle or virtual particles, but there's something there. The concept of nothing really does not exist in M1, and it does not because we must consider space-time as a real object in that EIM. And so all these other things must be explained in terms of that real construct. And in the case of M5, we tend to refer to those as MBPs or configurations of them. So again, using a metaphor, if we walk into a room in a building, we as humans walk into a room in a building, we might say there's nothing in there. Well, there is something in there. You just can't see it. It may be atmosphere. It may be water. It may be something else. If you can continue to breathe, then it's probably oxygen. It's got oxygen in it. If you collapse, it might be full of carbon dioxide, and you can't breathe, and it will kill you if you stay there. Halon fire extinguishers have that problem. They take all the oxygen out of the room. So the point here is that just because you can't see or perceive something in a safe manner does not mean that it's not in there. So we have to back all the way up, because the fundamental core constructs of any given EIM are highly systemic. They flow all the way up through every construct in the EIM. And for that reason, we need to be very, very careful about how we characterize our ability to reflect a unified universe. Our original systems review went through a thought experiment that we call the something versus nothing. It's on the website. We're continuing to update that because we just simply have so much information. We have to kind of gather it all together and get it in there, but it's taken us some time to do that. But anyway, it is there, and it does go through these details some more, but you do have to register in order to go see that. When we go and look under M1 and talk to folks that know the WMAP data set pretty good, and ask them about why the Big Bang banged, they may probably tell you that, it did that because of quantum fluctuations in a finite space were the random thing that caused the Big Bang to bang. But there's a lot of problems with that in terms of chicken and egg kinds of concept. That does not mean that there aren't philosophical issues. We still need to know where MBPs came from, etc., blah, blah, blah. But the real point of here is that we need because of the mode shifting of the medium, the way M5 defines it is that it creates a proposition that we need to take our focus off of the medium and onto the things in the reference frame. And because dimensionless nothing can't affect anything, so nothing can't affect something. And so we have to then focus on the something that's in the frame, and when we do that, the 800-pound gorilla in the room becomes, what does that architecture of that real object look like? How, and because of that architecture, what are its interaction characteristics that produce the phenomena and the properties that we witness? And we need to do a lot of R&D on that. But this is another example of where something superficially looks okay and we can get into it, but then we have to really start going through that decision checkpoint flowchart, make sure that we're not committing Langer epistemology errors. We have a good inventory of our abstractions that we are employing, and etc. And then we have to take that across all scales. And do we have one cogent manner of thought that can engage across all those scales that's consistent? And we do in the emergence model. We do not in M1. We have huge areas where different kinds of contemplation are effective: relativistic contemplations, Newtonian contemplations, and quantum mechanical contemplations. But when we try to cross scales, all kinds of things start cropping up. So we just need to back up and take a good accounting through the process, go through the decision checkpoint, go through the analytic stack of the translation matrices, look at the evidence chains, and then back up and then go down through the analytics of all of that and really make sure that our thinking is on par with the unified universe. Another paradigm of interest of nature, vacuum between M1 and M5, is an interesting paradigm to pursue, and again seems simple on the surface, but when you dig into it is a great deal more complicated than that, and is also related to other aspects in physics. In this case, it's permittivity, which is the electric constant, and permeability, which is the magnetic constant, and they have their own definitions for all that. But getting back to the point made on the earlier charts, that the concept of nothing really does not exist in M1, because we have to consider space-time as a real object there. And therefore, a perfect ideal vacuum would have to be defined in that context, in which case it would have to be an isotropically smooth lattice exclusively of space-time with zero energy. There can be no manifolds in it. There can be no virtual particles. There can be nothing. There can be nothing in there except space-time. And M5 defines space as dimensionless nothing. And so over there, a perfectly ideal vacuum is the absence of all MBPs. Kind of come to the same kind of emptiness, if you will. But then we have to also define permittivity and permeability, things like the Casimir effect, and mode shifting concepts like quantum vacuum plasma thrusters that are fairly exotic kinds of constructs. A comprehensive systems review, you start getting into all these details, and we very quickly get beyond the scope of this presentation. The point here again is that there is a way to mode shift these things, populate the translation matrices, go through the analytic stack, create the evidence chains, and go through this and connect out to 100% of all of these other concepts like permittivity and permeability, and go all the way back, connect all the way over to Planck's constant and the reduced Planck's constant. And it's holistically consistent on the M5 side, and it closes to unification. On the M1 side, we have the empirical results that we have, but they do not close to unification. And they never will, because the space-time mass interface precludes it. Taking then the paradigm of interest of matter and enabling the mode shifting of that concept, EIM to EIM. Here again, it's a very vast subject the more you dig into it. And, you know, a lot of those details are beyond the scope here. I keep saying that, but this is just, we want to bring out a few of these issues for contemplation here to illustrate how to enable mode shifting and the effectiveness of the analytics that you would experience in translation matrices that gets back to that decision checkpoint flowchart and across the generalized process flow, and what you need to document in terms of ISO 9001 or any of the other quality metric, and two, of making sure that your Six Sigma values are correctly assessed layer by layer by layer inside the translation matrices, and that they reflect the correct sigma values for the area of the translation matrices that you are working with, in order to maintain critical situationally aware thinking. So having said that, then and remembering the discussions that we had earlier about space-time and energy and blah blah blah, then matter in M1 is a manifold of space-time made manifest by energy. When we consider the space-time mass interface, and we know that in order to transition that interface, things get converted to energy, it obfuscates complex constructs like manifolds, like Hilbert spaces or Minkowski spaces, and that's what's been the primary inhibitor for experiments that dealing in things like quantum gravity and quantum mechanics and quantum computing and lots of other areas of endeavor. And humanity are spending a great deal of resources on those other topics. And we would argue that we could better spend our resources by refocusing these efforts into pursuits of M5, but that would constitute a fundamental restructuring of all of those other efforts. We've talked about most of these other issues under M1 already. The inability to accomplish unification under M1 leads to incongruous thinking, concepts and constructs like the multiverse and parallel universes and time travel, etc. Over on the M5 side, the emergence model holds that all matter, which is everything real, is a derivative of the intrinsic nature of MBPs, including the basic build process, which is limited by the other process, which is the failure mode process. We therefore can say that the fundamental entanglement function, limited by severance, configures MBPs into architectures of mass manifesting everything real. The MBP construed as a system implies then that everything real is a system or system of systems. That leads to the intrinsic nature. What is that intrinsic nature of MBPs? If we construe that an MBP may entangle with at most two other MBPs, that leads to lines. Some people might call them strings. Strings lead to knots. Knots lead to, the knot theory. And there are symmetry points there to be made of the knot from one perspective versus another perspective that are consistent. You could say that the intrinsic nature of the MBP might be able to entangle with at most three other MBPs each, which is fine. That's just another iteration of M5. It's not a different, that would not construe to be a different enumerated EIM. It would be an iteration of the emergence model rather than a new EIM. It could be, 6 MBPs can entangle or 7. Numerologists might like to see that number, but you then have to go back through the entire equation sieve and show that these things all can be made manifest. The systems review that we did poked at some of that, and we came back and said, well, 2 makes the most sense here to us. Other people can go pursue other things. Using 2 then produces cogent connections into knot theory, complied with the realm of C's. We were also able to see that when we get into knot theory, then we get into entanglement saturation, entanglement density. That leads to being able to make manifest concepts like dark matter using the single concept that we have of energy. So we have one cogent description for M5 that explains regular matter and dark matter in the same cogent, compliant with the realm of C's description. And it's the same kind of energy as every other configuration. There's not dark energy, and there's not some other kind of energy. There's just energy, and it is a function of the architecture of mass. So in that context, M5 is simpler than M1. It is more elegant. It has a single description, a single set of constructs, and they are compliant with the realm of C's, and they answer these questions. It's more elegant. Mode shifting then focuses away from the medium and onto those configurations of MBPs. That also leads to the concept of time, and that when we realize that time is an action displacement index of interacting architectures of matter within an event frame, we then realize that severance is what's responsible for consistency and constancy, and that because those are derivatives of the intrinsic nature of MBPs, i.e. matter or e.g. matter, we then find a holistic affinity for the M5 description, or EIM. It has more alignment with the unified universe, which we hold litmus. And because action is always positive, so too is the arrow of time. If we get over to M1, we cannot explain why experience, living life, is always positive. We do not understand over in the M1 side why things like time travel are inconsistent with nature. Over in M5, we do understand why time travel is inconsistent with nature. It is because action is always positive. That results in the arrow of time always being positive. People often ask me, where were the aha moments that in all of this? And now in hindsight, I've had so many of them, I really kind of lose track. But they come from all different areas of the translation matrices, but they also come from how we quantify and codify the paradigms of interest or of nature. And that is the leftmost column of the 2D articulation layer. And you need to do that in as neutral a manner as possible so that the paradigm can then be declared across all of the different EIMs that you choose to employ for a given investigation. You need to remember too that encapsulation is going to require the description of how that paradigm is made manifest by the EIM to be complete and comprehensive. We do that so that we can then recognize the patterns and how of relationships within the EIM relative to the patterns of a different EIM and how those things change down through the analytic stack, which then translates into the evidence chains that we're ultimately going to use in the analytics that result in the unified treatise that gets produced at the end. And as we loop through the decision checkpoint flowchart and reduce or eliminate Langer epistemology errors that hide up in different places, and sometimes you don't know that they're there until you go through that loop. Higgs fields, it's probably unfair to single them out as an example, but there are cases where constituent constructs behave in concert. Maybe a better example is one from music. and it would be a symphony orchestra. It's the difference between an individual instrument playing versus that instrument in a large orchestra playing a symphony. Sometimes you can hear the symphony, but you hear a set of instruments more than another set of instruments, but they all come together to provide the rich tapestry that is the symphony as a whole. And that's something that you just simply have to experience in the audience of a piece that gets played by those guys. You know, we just need to be careful with the how the paradigms of interest are articulated, and that's kind of the point of this chart. So as we then back up from the whole recognition phase of the generalized process flow in terms of mode shifting M1 to M5, you know, were there a specific set of aha moments that came holistically out of that exercise from the original systems review? And the answer is, yeah, there were a ton of them. A few of those are listed here in these bullets. I will reiterate what's that first set of, you know, a couple sentences there, is that the experience of going through that is, I can only describe as ineffable. It's something that you go through when you see ultimately when we're able to get all of the details of the systems review, and I'm sure people will crawl all over this in the years to come. But for right now, you know, the focus of contemplation shifted away from the medium and onto the real objects in the event frame that established valid geometric basis was stunning. And it was a recognition of that was incredible. Being able to ultimately define space as dimensionless nothing was very hard to do, and it took years. And so I can sit here and put this on a chart now, and it looks, and just, you know, we look at it now as, oh, he just wrote that. Well, no, that took a great deal of reverse engineering and a review of a large number of issues. As we've gone through these last couple of charts, nothing is ever straightforward. There's always greater detail, and you have to systemically go through the relationships to the finest level possible. And you have to understand what that evidence chain looks like and what that pattern looks like. And words simply fail me to describe how powerful that all is. But if you can survive that, and you can do that, and you can ultimately articulate that single cogent paragraph, then you've accomplished something, especially if it systemically relates to everything that's real. The other aha moment came from the intrinsic nature of MBPs. Must be able to derive every other concept and construct with, you know, simultaneous truth spanning not just all of science, but philosophy as well. The only thing I know in information science that's related to that is the representational state transfer. It's called REST architecture. You have to be able to relate. You know, in the past, we've approached unification as if the only thing that mattered was physics. I guess a better way to say it is that it's necessary but insufficient to integrate physics. You also have to integrate everything else. And if you don't have a clear path from those equations to art appreciation, for example, and the symbology through that philosophy that Suzanne Langer was able to articulate, or over to economics that Ludwig von Mises was able to articulate, then you really haven't accomplished unification. You've found some detail sets that match and align from an epistemological point of view, but that's necessary but insufficient to accomplish unification. If you can describe the universe, the unified universe, bang to bang, and we did do that, then you also are required to go the next step and say, okay, well, how do those things fit how does everything else dovetail back to that? So when we say that this accomplishes unification, it's a really big deal. It's epic. Even having said that just because we've done this, we've only lit one small candle in the corner of a very large space, a very large place. There's a great deal more work to do. I mean, and it's just the merest glimmer of an insight is, all of this is what that manifests. It's just, we have way more work to do than any single people can do. And so when we assigned, C got mode shifted away from tradition to mean severance, that rippled throughout science. I mean, if you look at all the different places where the term C is used, and you start reading those equations from your traditional point of view, and you understand that C now means severance, you read those equations fundamentally different than you did before. You see things you didn't understand before. You begin to understand the implications of architecture, the fineness of the relationships that architecture represents. It's a big deal. And, it fundamentally redefines the concept of rapidity. So rapidity means one thing over in M1, but it might mean something similar in M5, but it means the fundamental insights that it delivers are a great deal more powerful. And I'm reminded of Richard Feynman's presentation about what we know and what we don't know. And I think there's a link to that on the website, and you can go look at that, or certainly on SolREI Studios. But, in his description of what we can do with science when we have two theories that are simultaneously true and trying to figure out which one is best. Our answer to that is if it closes to unification and it has a greater affinity to the unified universe, then that theory is best. The fact that black holes grow, if you look at an inventory of black holes and realize that they get bigger and they grow and they have greater mass, that's important because it means that there's no such concept as infinite compression in nature. And when you realize that, and you realize that infinite compression is the corollary to rapid expansion, which is necessary in order to have the inflationary theory be as cogent as it is, then the inflationary theory unravels. And it means that we have to go back and look at the Big Bang. And that was a huge, huge deal as well. It also meant that we needed to go back and review the cosmological data set and a lot of information from astronomy and astronomical sources. So there were a lot of aha moments in the recognition phase, and this is only just a very, very few of them. But just wanted to articulate those and get you guys to start thinking about looking for aha moments, in every corner of what all of this holistically represents. So all of our time so far has been in the recognition phase of elegant reasonism relative to mode shifting, an introduction to mode shifting M1 and M5. And we've had a lot of aha moments. We've talked about abstraction inventory, and we've talked about starting to think about populating translation matrices in the analytic stack. But the illumination phase is where we actually go and do that. And that's the next phase. Powerful as the other phase was, and just seeing what the problem was or the depths of the problem and challenges that we've historically faced, this next phase illuminates those things. And then really the purpose of this phase is to illuminate in context of being able to illustrate those things. So when we get into the recognition phase of elegant reasonism across the generalized process flow, one of the first things we have to do is pick out the EIMs that we're going to use for our particular investigation. One of the rules for elegant reasonism is that one of the models that you choose has to close to unification. That is to say, it must be fully compliant with the realm of C's. Today, the only model that does that is the emergence model, and we work most often with M5, and so M5 is a foregone conclusion at the moment until somebody comes up with another EIM that closes to unification, in which case we could pick that model. So anyway, we'll talk about that M5 in just a minute. M1 represents the model that most people will probably pick. Don't know that that's always the case, but and most people attribute predominant thinking in physics to Einstein. And there's a bit of an issue here because we have to distinguish M1 from M2 and how you want to handle the concept of mass. Predominant thinking today holds that mass is variant across physics, and how we deal with inertia and momentum and things like that as we approach relativistic numbers in astronomy and cosmology and advanced astrophysics and nuclear sciences and other areas of science and quantum mechanics and even quantum computing. And so it's important to, whether you want to, how you want to handle those in your investigation, what you pick. But for the purposes of this presentation, we've picked M1 because all that other detail is just too much to talk about in a presentation like this. It is important to understand that any EIM that employs the space-time mass interface is going to be precluded from closing to unification, exactly because that interface precludes your ability to employ a common geometric basis point, and that in turn precludes you from being able to fully couple all of your reference frames and all of the real objects in those reference frames to a common geometric basis point, because they turn to energy when they try and transit that interface. Knowing that and recognizing then, because we went through the recognition phase, that M1 is a logically correct model, as is M2. For the purposes of this presentation, we're going to pick M1. And if you need more detail on the distinctions between M1 and M2, I refer you back to the concept of mass article that Dr. Lev Oken wrote. He did a really good job in that article of explaining the historical belief systems of the relevant scientists of the day. And the variance in mass can really be traced back to Wolfgang Pauli's work, not Einstein's work. We've already shown you the chart where Einstein said in a letter to Lincoln Barnett that it's not good to introduce any other concept than rest mass when you write out the equation. And we've shown you his equation. We've shown it to you in his own handwriting in German. So anyway, but you can go back and look at all that and see and understand that historical set of circumstances. The elegant reasonism demands encapsulation. And again, everything needs to be quantified, codified, in enumeration and in an iteration, exactly to inhibit what we would otherwise call scope creep, which occurs when we tweak or different factors and facets. We need to not do that, and we need to not do that exactly because models or these core constructs within these models are highly systemic. Any little tweak that you do at the bottom and any one of those little details has massive implications when it flows back up through the abstraction layers into the level at human levels, where we're at the what I call human scale, and then out to the cosmological scales. So we need to be very careful about that. We need to preclude scope creep. We need to quantify, codify, enumerated EIMs, and then we can iterate them as many times as you want to, but you have to declare what your iteration is. And when you do that, that means that moving inertia and momentum, etc., into the variance mass, it obfuscates the underlying mechanics. And so M2 forces those considerations. And I'll just say right off the bat here that M5 has more affinity with M2 than it does M1. But we want you to try and look at as many independent variables and factors and constants as possible. The cogent description of the emergence models M5 is this next chart, this chart 25 in the presentation deck. If this is the first time you've encountered this, then please hit the pause button and just read this. We've talked about it in other videos and explained that we didn't just sit down and write this. This was the culmination of an almost 20-year systems review in going through a lot of detail, and it was a lot of hard work that went into being able to reverse engineer this from what it was we thought we knew. Okay, we're 26 charts into this presentation, and we're only now getting to the point to where we can really get to the heart of the matter and begin to talk about actually mode shifting paradigms of interest, model EIM to EIM. And it's enabled, by now that it's enabled through translation matrices. You know that the intrinsic nature of translation matrices is three-dimensional. There's a 2D articulation layer that's at the top that describes the basic manifestation of a given paradigm within that EIM, and whichever EIMs you pick, and then it goes down through the analytic stack. My personal preference is to articulate all of that in manuscript form as opposed to parsing it out into a mathematical three-dimensional matrix, because there's prose that needs to go along with that positions maybe historical information or people who have pursued some area of investigation relative to that particular paradigm, and you need to link their work or position their work. And so to me, it's always been easier to use manuscript form than another form, and then ultimately you need the prose anyway, and so it's just easier for me. So, but you can do what you need to do. As you've also seen from the earlier charts, about once you start digging into something, that it almost always inevitably produces greater detail as you pursue things down to their foundational elements. And it is for that reason that we created the ISO 9000 unification tool. You don't have to use our tool. If you don't like our tool, then use your own tool, but it needs to be able to quantify and codify all of that detail relative to and respective of the different, not just EIM, but the specific iteration of the EIM, so that the entire investigative team can stay on the same page. And so they need to use the same instance of the same tool, so that when you're in a conversation or a meeting, everybody is on the same page, or you at least know which iteration of an EIM everybody's talking about. If you've done the quantification and codification properly, then they will know that. And that's important in terms of critical situationally aware thinking, to do that so that people are focused properly. I would also say that mode shifting needs to be deployed transformationally. If you're not really aware of or familiar with what that means in terms of enterprise business management, then I would encourage you to watch the In Unification's Wake Part 5 Business Impact on SolREI Studios online. And obviously you want to do that in the context of knowledge management sciences. So enabling mode shifting then is the translation matrices, this background table that has M1, M2, M3, M4, M5, and 6, and then the paradigms is that top view of the foreground table. The foreground table shows you the underlying layering of the analytics stack, and you can click these individual things. Each one of these layers is articulated in detail on the website, what it means, but the idea is to take in the 2D articulation layer, that intersecting cell, and explain how that paradigm of interest is made manifest in that cell, and do the same thing for the other EIMs as you go forward for your particular investigation. And on the left here, that column are the different EIMs that are recognized by Elegant Reasonism, and hopefully at some time in the future there'll be M8s, M9s, M47s, or whatever, and they'll be fully compliant with the realm of Cs, and we'll have an ever-increasing precision and an ever-increasing accuracy, or an ability to reflect the unified universe as a function of Elegant Reasonism, And so this basic process, the generalized process flow, is not going to change if we have better, fully compliant EIMs. It's only going to get better. It's only going to get stronger. And so from an epistemological point of view, elegant reasonism is the path forward in that context. And there's a couple of points here, is that as you go through and you discover greater detail, as we've talked about in some of the paradigms of interest already in this presentation, it may mean that you need to add an additional row in your 2D articulation layer to make sure that you're adequately. So for example, if you're doing vacuum as the first paradigm, and you say, oh, okay, well, I now need to do the electric constant, and I need to do the magnetic constant, and you can add those rows, and then you have to go across the number of EIMs and explain how that becomes manifest, and then carry that all the way down through the analytic stack here, and make sure that your thinking in terms of how you articulate that is cogent in terms of the realm of C's. They're cogent, they're coherent, they're concise, they're etc. I mean, you can go read all that online. But if it's fully compliant with that on the decision checkpoint flowchart, and you're looping through those, and you can do that effectively, then we can proceed to the next step. But right now, we just want to make sure that we are articulating the individual paradigms as a function of the lens that is created by the particular set of EIMs that you choose here. And I'll just mention, and I don't recall spending a great deal of time on it before, but when we created these, it became apparent that if we set some particular set of values to 1, then M5 is capable of emulating M1 or M2. And that's kind of a software statement or a spreadsheet statement, depending on how you've implemented your investigation. But the point there is that if you're exploring chemical linkages, or you're exploring interaction relationships in terms of some physical processes or phenomena, then it's a useful tool to be able to take M5 and emulate M1 or M2, and that's the purpose of M4. And so sometimes if you don't know what the M5 answer is, it's helpful to be able to surround it with either other paradigms of interest or new insights, and you can sometimes do that by emulating M5. And again, that's the purpose of M4. So, and again, the ISO 9001 unification tool is where we codify and quantify our abstraction inventory, and that inventory then gets populated against the translation matrices that we use. And fundamentally, this is how we implement mode shifting. And again, mode shifting is not just moving 2 columns on a table. Mode shifting is a mode of thinking. This is a knowledge management concept. It's not just a mathematical concept. And when you change your mode of thought, you're changing your mode of thought across this entire analytical stack, EIM to EIM. And there's a lot that changes because this is why you can't just tweak some facet of M1 and think you've solved the thing, because you have to show the systemic relationship pattern changes up through the entire analytic stack and across all scales. And so this is a very important chart, and you can study it ad infinitum, and you could probably spend a long time doing this. But there are layers here where you have to, focus on the articulation of the paradigm relative to each EIM. You do the context and source of your articulation. That's where your historical reference points would come in. etc., all the way down this analytic stack. And so you can go through and read the descriptions for each one of these on the website and understand what you need to do in order to make that thing manifest, make that paradigm of interest manifest. And this is what enables the fundamental concept of mode shifting. Okay, so let's mode shift space and time, the concepts of space and time. Under M1, the first three dimensions are said to be of space. If they are of space, then we need to understand how manifolds of space manifest real objects. And that's when we have discussions about the space-time mass interface. Then we also have to have a discussion about geometric basis points. We already know that the space-time mass interface precludes the use of those. That's one of the reasons M1 will never accomplish unification. But we also understand that tensor mathematics, if you're not familiar with those, is the math that we use for calculating three-dimensional space or four-dimensional space. Dimensional mathematics is how we use tensor. So there's a space-time tensor that can also include the fourth dimensions, and I think there's a lot of people who will tell you that, there's discussions about, is it 11, is it 20 something, how many dimensions do you need in order to describe under M1 what reality looks like. And on paper, at least in that context, time is bidirectional. It can go forward or backward. But then because we always hold the unified universe as litmus, we then are required to explain why what we experience is always positive. And we can't do that under M1 because it appears, at least on paper, that we ought to be able to do things backwards. And sometimes, because of symmetry, we get results from an experiment and it appears as if time went backwards, but it's really not. And so you really have to dig into those experiments and mode shift them to understand that all they really did was back out of the same alley that they drove into. And the act of backing out is just as positive as the drive in. So you then have to ask the question, did it close to unification? Are you fundamentally in a different place than where you were? And the answer is no, probably. You didn't close to unification, and no, you really didn't accomplish anything net new. Then you have to get into space, time, and energy. They're considered real constructs, but then you also have to consider the engineering metrics for those, stress, tension, etc. And we've talked about some of those points earlier. But you have to be very critical with your language. And so in M1, the first three dimensions are of space. In M5, the first three dimensions are of MBPs. And so it is the MBP that manifests three-dimensional real objects, not space. And over in M5, space is dimensionless nothing, so it's essentially irrelevant in every conversation. And so what we need to do is shift our thinking away from the medium and onto the real object. And what is the architecture of that real complex composite configuration of MBPs? How are they made manifest? How do those kinetics come alive? How does that fit into the fundamental entanglement function limited by severance, following knot theory, etc.? And there's a great deal of R&D that we need to do here. We have made those suggestions to the National Science Foundation, and we are trying to pursue as aggressively as we know how to set up a framework and the capabilities to do that research on behalf of industry and the global economy. I'll just mention here too that Summit is currently the most powerful, or one of the most powerful computers on the planet, and it's funny how we might calculate what that means, but Summit is generally capable of investigating hundreds of atoms. What we need to enable is this holistic process in order to pursue our ability to reflect the entire unified universe. And the system that we need to use to make those explorations is likely at least an order of magnitude larger than Summit, or more capable than Summit. And so there's a great deal of things we need to do. We need to work with industry to make that happen, with the National Science Foundation, and we hope that they listen to what we have to say and why we need to do it. Mode shifting mass. I would encourage you to click the links on this chart and explore these different sets of materials. So if you want, you can hit pause, make sure you've read the chart. I would also remind you that if you do not have a copy of the PDF version of this set of presentations, that they are available on SolREI.co under the info tab in the user library in the SolREI folder under presentations. Go download the latest version of this presentation. Make sure you have that so that you can, in fact, click these links and go to explore that set of information. Having said all of that, it's important to know that one of the things that happens, one of the phenomena that happens when we mode shift, and you really don't see this until you start looking at that analytic stack, and probably not even until you get to some of the lower layers in that set of analytics, is that if you look under M1, the set of known knowns and known unknowns and unknown unknowns changes between M1 and M5. What you thought was the answers to the what, when, where, why, and how questions may be one thing under M1, but they are different under M5. And from a knowledge management sciences point of view, that's a fascinating phenomena to see, to transpire, and to be able to illuminate and illustrate in terms of evidence chains is a very, very powerful capability. So for example, under M1, we would use the M0. If you back all the way up to that Einstein chart, you'll see that he used the M sub 0 to describe rest mass, whereas in M5 we use complex numbers to represent that mass because it's an architecture. It's a complex composite architecture, and in order to represent that architecture in a dynamic kinetic kind of way, we really need to use complex numbers to do that. And when we distinguish M1 from M2, for example, and we look at inertia and momentum, and we look at our ability to articulate a kinetic architecture, we really need to externalize those other parameters, and that's why M5 has a greater affinity with M2 than it did with M1. And so it is for that reason that it has that affinity, but that's one of the reasons why, in terms of if you're in an investigation and you're trying to find out something in M5 that you don't understand or has not been previously articulated, and you're trying to ferret that out, sometimes it's easier to surround the problem with an M1 manifestation and an M2 manifestation, and you see those distinctions and how those patterns shift as you mode shift them, and then the M5 answer to those very questions, in my experience, has been forthcoming. And so in that sense, M5, the emergence model, and elegant reasonism tend to be what I call self-clarifying. It's almost eerie that it works that way, but that's my experience. So as we go through here, it's important to go back to that cogent description of M5 and realize how rapidity plays into that cogent description of MBPs, and that the processes that are a derivative of that intrinsic nature manifest into the real systems that constitute real objects in event frames and local frames. Mode shifting energy. This is one of those concepts that's been liberally applied, especially in science fiction and the media and what it is. But energy under M1 is the potential to do work or produce heat, the capacity of a physical system to do work, or the quantitative property that must be transferred to an object in order to perform work on or to heat the object. In M5, energy is the ability of relative and relevant architectural mass to do the work instantiating any force, including heat. And see the basis of, the paradigm of interest chart on bases and forces. Thermodynamics then is understood as a function of action relative to and respective of complex composite architectures of mass in context of the intrinsic natures of MBPs, and I would add there, in an event frame. And so it's an event frame it could be in a local frame too. It depends on how you're doing it. But the event frame is between sets of real objects. A local frame would be internal to a real object that's not interacting externally beyond itself. But depending on how you want to do that, to understand the relative thermodynamics. Quantum rotors is an example there of a discontinuous geometric map that describes an object that, it's something that's rotating on an axis around something that's influencing the rest of the architecture there, just to provide an example. All energy characterizes the ability of architectural mass to do work as a function of the intrinsic nature of MBPs. And the key factor there under M5 is to remember that it is the fundamental entanglement function limited by severance that is the ability to deliver that force through that work. And it is important also to remember that the configurations of MBPs that are produced by those functions create structure. They create architectures. And architecture can be stronger than the constituents. I know engineering students are often challenged to see how strong a bridge they can build using straws or toothpicks or popsicle sticks or something, or build a boat out of something that would otherwise would sink. So there's lots of different examples of buttresses in buildings like Notre Dame that create structure and architecture that's stronger than the constituent pieces would otherwise be. And so that's one of the reasons that the whole R&D effort behind architectures of mass is so very vital going forward. But in terms of energy, what we need to do is understand how these architectures deliver their ability. And in order to do that, or in the process of doing that, we will understand better what energy really is and means relative to the emergence model. So when we look at the holistic set of ahas we had from the illumination phase, we've already done the recognition. We had a bunch of them over there, and we get through our ability to fundamentally and basically mode shift back and forth M1 to M5 in terms of the core constructs. And we back up from that in the translation matrices that articulate all of that. There were some ahas that we had that really didn't occur until we could be able to do that. One of those was recognizing that we had accomplished unification. We had accomplished unification years before we realized we'd done it. And so sometimes it's a matter of the forest and the trees kind of thing. But gravity is one of those things that is in M1 is a phenomena resulting from mass warping space-time in M5, where it's a force instantiated by the work performed through the intrinsic action of the gravitons architecture. What happens when you realize that is you suddenly realize Euler's gamma and beta functions in articulating convergence issues relative to knot theory and pole residues that result out of that. You then realize that electromagnetism is not the only polar construct in the EIM, that gravitons are polarized also, but they are polarized along high mass, low mass architectures. And that is a function of their architecture. That much we know. There's a great deal we don't know about that yet still, but that much we know. We also know that the more distant a graviton is from its source, or where it is anchored to the high mass object, that it tends to want to seek that high mass area that is now behind it because of distance. And what happens at that point is that the graviton's poles reverse and they start linking backwards. And like in electromagnetism, when the poles reverse, they repel. And that's the reason the galaxies are flying apart the way they are. That's why galaxies that are distant from one another repel each other. And that's why they are now flying off to go. And so when you read the Bang to Bang article and you understand the implications of architecture holistically in context of everything we've done here, then it becomes ineffably powerful. Words fail me. It's a palpable, tacit experience is the only way I can describe it. So the whole reason that we get, as we go through the generalized process flow, the reason we illuminate things in order to accomplish mode shifting is, and we want to do that effectively, and we measure that effectiveness in terms of the translation matrices and the analytical stacks and whatnot, is because we want to analyze. There's a certain set of analytics that we want to be able to perform that are holistic to each EIM's capabilities and capacity to reflect the unified universe. The unified universe is unified whether we think of it that way or not. And so it's, where our theories don't couple, or where our insights don't line up quite right, or maybe there are logic artifacts, or there are concept compression issues, or there are other kinds of challenges that we are trying to get to, is where we want to focus our efforts when we get into the analyze phase of elegant reasonism. In the analyze phase of elegant reasonism, there is probably no more, I'll just say, frustrating paradigm of interest or nature than encapsulation. And it represents a barrier to entry in accomplishing unification, but it also represents a barrier in terms of effective ability to articulate an EIM or the results of an EIM to someone who cannot perceive that other EIM. You almost need to go through the entire elegant reasonism process in order to represent it. And arguably, everybody would probably love to have had this presentation before we did all of the other presentations, but we would have lacked context had we done that. This presentation that is an introduction to mode shifting requires some fundamental understanding of the process, of the decision checkpoint flowchart, and situational awareness that unification is achievable. And gaining that precipice, there is a path to that precipice. Langer epistemology errors creates this false premise that tricks us into believing that we're interpreting reality directly when in fact we're employing abstractions of it. And the implication of this is that it's just very difficult to penetrate these encapsulation boundaries from within any given EIM. And it is actually a rule of elegant reasonism that you don't penetrate that from within the encapsulation. And so that's part of the rule that elegant reasonism has, to iterate the enumerated EIM rather than tweak it and continue from within it. That may be you may do some tweaks to see what the tests, and in terms of testing the boundaries, but you don't want to do that in an ongoing fashion without iterating it in your database. You're either in the ISO 9001 unification tool or its equivalent, exactly because of the systemic nature of all these things. And part of the frustrating issue here is that if you get to this point in the process, it means you've already gone through mode shifting, you've already built your translation matrices, you've already gone through the Langer epistemology awareness, blah, 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 blah. And you get over here and you're ready to start into your analysis, and you've had a flash of insight, and you turn around and go, oh my God, I got to go do all that all over again. And yeah, that's what it means. You got to iterate the model and go through all your checks, all your translation matrices, all your metrics, and make sure that you fully comprehended what the implications of whatever your flash of insight was. And often you'll have that insight will cascade into other insights that may be even more powerful than the initial one. But that's the benefit, that's the reward for having that flash of insight and for going back through the loops again. Elegant reasonism is notorious for sending you back through the loops. And so all I can do is to encourage you to wade into them and go through the loops, and don't be complacent in terms of your recursiveness in going back through those things. And you'll go through them so many times that sometimes it seems like it's wasting your time, and then you'll be noodling on something at dinner or someplace when you're not thinking about anything, and it will suddenly come to you what the implications of your whatever the insight was meant to the work that you're undertaking with your investigation. And so part of this is satisfied with the quality management system standards, processes and metrics, the ISO 9001 QMS process standards, and other standards, Six Sigma or root cause analysis or any of that. And you can document all of that there so that other people can follow in your footsteps. The core message and takeaway here is respect encapsulation. Don't let it get you down. Hang in there. You can do this. You know, as you conduct your analysis, there's a number of implications that will come out of that, and everybody is going to experience probably a different set of those depending on what your belief systems are and how you got to wherever it is you are in life, and understanding the implications of all this. But the historical review that you conduct back in the recognition phase often produces some interesting insights from notable authors down through history. The one we picked out here is one by Carl Sagan, that he wrote a book called The Demon Haunted World, and it's Science as a Candle in the Dark, and it's absolutely wonderful book. Some of the things that he talks about there are, skepticism, and we've tried to, on this chart, we've tried to portray some of the implications of Langer epistemology errors against that framework of skepticism. And the implication is that we now need to recognize those implications in context of human physiology relative to the traditional epistemologies of empiricism, rationalism, and constructivism. And we need to understand the detail sets within those epistemologies. We need to understand how they're rationalized and how they're justified relative to and respective of the unified universe. Elegant reasonism requires us to consider or it seeks truth as a function of the unified universe. Unification as a philosophical predicate priority consideration entering science. Scientific theories that, consistent with Richard Feynman's point in his speech on knowing and understanding, means that we need to consider this larger framework of metrics relative to theories that are simultaneously true. And if we have a set of theories and they don't connect across scales, or they cannot be fully compliant with the unified universe, then if the results are simultaneously true and they all conform to experiment, then we need to drop back and say, okay, well, did it close to unification? Yes or no? Because there's a larger litmus here, because the universe is unified whether or not we think of it that way. It doesn't care how we think about it. And so it is unified because it works. I mean, we have to hold that self-evident because it's here, we're here. And that means after we have all this critical situational awareness thinking, we then need to drop back and say, we need to really understand how phenomena emerges from architectures of mass and the interactions within an event frame. And that becomes an R&D quest. And the 800-pound gorilla in our room here is that we really don't understand these architectures of mass, and we need to put a blowtorch on that and focus on that. And again, we have asked the National Science Foundation to take this under a high priority consideration. Part of the analysis phase is the litmus tests. And if we look at our reference frame, the event frame and the local frame and the event frame phase steps, EFPS1 is the cascade towards severance. EFPS2 is analogous to what would be called the interval in M1. It's geodesic cruise in interstellar space, essentially, or space. EFPS3 is the initial encounter or initial interaction. EFPS4 is capture in the context of merger or resonant feedback between interacting systems. EFPS5 is max Q, maximum energy, however you want to think about that. EFPS6 is the subsidence frame, and EFPS7 is the endurance frame. And again, the local frame is a system that you're looking at that, and all of the references to geometric basis points are focused inward. They're not focused externally to any other real object. And so both of these frames are scale invariant. They may be nested within one another. When you back up from that, however, you then say, okay, well, then there's a certain energy signature and there's a taxonomy that associated with that. And we've articulated that on the website. And relative to performing a litmus test, we then need to say, okay, well, let's take the bang to bang article, for example, and say, okay, if severance is a valid concept, then, and the bang to bang conclusions are correct, then we should be able to look at the astronomical data and database, and we should see examples of that. And the question then becomes, well, do we see those examples? And the answer is absolutely we do. And here are 6 at the bottom of the screen that are potential candidate examples for what we might call collision class objects within the astronomical data set. They fit certain locations on the energy signature taxonomy. They are consistent with the emergence model and the event frame phase steps. When these events transpired, the initial part of that event would have been at EFPS 5. What we are seeing in these images is in EFPS 6. And, long term, once all of the normalization has transpired, we then move into EFPS 7 in the endurance phase. But the actual event is probably not going to be visible like these examples are. And so the real point here is that even when we back up from having created the event frame and the local frame, and the energy signature taxonomy, and all the things we've already talked about. We are finding correlations to the unified universe in the existing astronomical database. And that leads us to the conclusion that elegant reasonism is a correct and proper way to assess and address the unified universe. People often say to me that this has taken us almost 20 years to get to this point. You know, why did we keep going? Why didn't we give up? Why don't we give up? And the answer is mode shifted insights. Once you have a set of translation matrices and can mode shift the selected EIMs, in this case we're doing the core constructs between M1 and M5, and you can holistically back up from that work effort and then look at it from a holistic point of view relative to the translation matrices and the analytic stacks and all of the results that come out of that, what you're going to find is that the landscape is littered with clues that have been there all along. They just lacked context. They lacked awareness, situational awareness of the implications of Langer epistemology errors and abstractions and layered abstractions, fate of replicate errors. But the clues are there in particle accelerator beam alignment. They all use rapidity. A Bell inequality test suggesting that the speed of entanglement is superluminal. Neutrinos going faster than light. And there's just clues everywhere. And what you're going to find, once you've experienced these and you for yourself, these experiences will be tacit and they'll be palpable. They may be ineffable to describe to someone else who has not experienced or is not on the precipice with you what this all feels like, but it will excite you and it will motivate you to want to continue and push forward and expand the envelope of knowledge and help us carry this on. And the insight that we need to move away from the medium and onto what is in it is very vital going forward. I can't stress enough the need to conduct a set of R&D on architectures of mass so that we can better understand phenomena and property emergence and how these things are made manifest. What we've done so far is interesting, but the road ahead is even more exciting. And for that, I'm very envious of the younger generations that will follow back in our footsteps and carry this all on forward, because they're going to be the ones who do the yeoman's part of work here and will carry this all forward. The analytical phase, just like the recognition phase and the illumination phase, had its own area of aha moment. They came so fast during our original systems review that it became a continuum almost. They were constant during some periods of time. And they spanned the spectrum of philosophy and science, and so much so that they reunited in one sense philosophy and science once again. We needed to recover the roots of science in terms of it being a philosophy of nature, and we understood more why unification needed to be a philosophical predicate priority consideration as we enter science. Because of once you're in science and you're making assumptions based on what it is you thought you knew, without the framework of elegant reasonism, you are completely unaware of contextual changes that are highly systemic and driven by abstraction layers representing the lowest ordered details that you may be assuming. And one that immediately comes to mind is the absence of a geometric basis point. We are so used in familial ways to rationalize that away, and it's like, oh, you don't need to know that. Well, yeah, you do need to know it, and you need to understand why that's important. And without understanding that, you're never going to be able to fully couple a reference frame. And so things like that are examples. But when we started looking for clues for severance, for example, and we were reviewing Einstein's coefficients of emissions, we didn't see it there kind of sitting in front of us, But what we did find is when we went back and looked at the set of equations that lead to those coefficients of emissions, the immediately prior sets of equations, we do see it because those mathematical equations reduce, and C leaves those equations and they reduce into the coefficients of emissions that Einstein published and wrote about. And that's severance in action. The photon left the system and it reduces out of those mathematical equations. And that insight, it's like it hit us like a ton of bricks. It's like there is severance in action. The analysis that we did of synchrotron radiation, a synchrotron is basically a particle accelerator. It's full of electrons spinning in kind of in a donut. And there's no atomic structure there. There's only electrons in those devices, those machines. And they emit photons. And they do that based on the centripetal force imposed by the magnetic fields containing the electron beam. And it's kind of a long story, but that's what led us to understand centrifugal force and the entanglement there and EFPS1, and that ultimately led us to unification. We were able to then take that and apply it to the other fundamental forces, including gravity, and in the event frame, and it fully coupled all the forces in the context of and relative and respective action, to the architectures of mass that produce the work instantiating those forces in the event frame. There were no atomic or subatomic shell transitions because the atoms were not present at all. And so it allowed us to understand that in each of these different cases, the mechanism that's imparting the centripetal force that produces the photon in the system is entanglement. It is the fundamental entanglement function limited by severance that produces those photons. And that's why we have the consistency for the speed of light and the constancy that we do. It is fundamentally intrinsic to the intrinsic nature of MBPs. You can go through the whole set of physical properties. We listed specifically reflection and refraction, but the point is you can mode shift all of that across the holistic context of elegant reasonism. And these were major ahas. We were not expecting any of this. I mean, I have said many times that unification was not the original quest. It was not something that we intended to sit down and do. It's something we stubbed our toe on and went, oh look, we just accomplished unification. What does that mean? And then that's what exploded and led up to all these other places. But the architectures of mass are not like baseballs or golf balls. They're not hard point objects like a point mass might be considered, with composites inside it in terms of how those objects are created. They're more like dandelions. They're wispy in some cases, and it is that wispiness of the character of the architecture that creates the illusion of wave-particle duality. The more ethereal elements of the architecture may entangle, for example, in the two-slit experiment, that allows the main body of the architecture to swing around an edge as it's coming past it. And it creates that wave, the illusion of the wave on the other side of the two-slit experiment. And it is that same characteristic that produces glories that are witnessed by pilots. And we have a video of that up on the SolREI Studios channel. You can go look at that, and that's us flying in a Cessna 172. And there's nothing on the upstream side of us except our atmosphere and our sun. So it's our aircraft with a cloud below it, and you see the glory projected onto the cloud. But it's exactly the same set of circumstances that are in the two-slit experiment, and there's consistency, there's constancy, it conforms to the realm of C's, blah 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 blah. We can mode shift all of that, and it's really kind of cool. But when you start to mode shift these different entanglement experiments, and we take the frequency arm through a gravity field and then look at the same set of questions and issues that Dr. Lev Oken did in his concept of mass, and then apply that in terms of the context of an architecture of mass, architecture becomes something that we need to pursue from an R&D point of view. This means that it is the articulation of that that is true, not just for the master event frame, but for all nested frames, both event and locally focused. So part 2 of the analysis phase, aha, I guess one of the points that I wanted to make sure got into this presentation was that the analysis phase of the initial systems review produced what I call an aha laminate, not just an aha moment or a continuum, but a laminate, and it reinforced and solidified our approach. And what I mean by that is that it wasn't just the dovetailing of the data and the thinking within a given EIM that motivated us, though that helped, but the very processes that we were using, the emergence model general process flow and the decision checkpoint flowchart, against that set of data, it reinforced that that was the appropriate manner in which to go about looking at all this stuff. And they together holistically is what that's what produced that laminate layer. So they're self-reinforcing to the point that we were worried that we were not creating a self-diluting environment. And when we reviewed that in an objective as a manner as possible, what we found was that elegant reasonism has a tendency to be self-clarifying and reinforcing of new insights that are in alignment with the unified universe. And has been said more than once that the universe is trying to teach us something here, and it tends to want us to know and want us to understand these processes, and it kind of sticks them under our nose. Once you've gained this precipice, you'll see what I mean by that. But even to the extent that if you want to pursue a net new, fully compliant EIM, this process will support you pursuing that. Godspeed, I don't want to do this again. But, the emergence model was enough. I'm kind of done. So when we look at the fundamental entanglement function limited by severance, both of those processes are a derivative of the intrinsic nature of MBPs, and they configure MBPs into complex composite discontinuous architectures of mass following knot theory. The discontinuous architectures takes into account things like quantum rotors that where you have one structure rotating around another structure, potentially at superluminal speeds, if the architecture can sustain the integrity of the configuration beyond normal severance limits. But that's a whole area of R&D that we need to go through and understand. Structural engineers will probably immediately grasp what I'm talking about there. Entanglement density and saturation, one of the big ahas that we had when we were looking at entanglement density and saturation was relative to these configurations, was not just explaining things like dark matter, but it presented us with the concept that these complex composite architectures that are already in the standard model of particle physics might have dark components inside them, and that there's a blended view of these architectures, and that saturation and density may go to different places in different architectures, and that you may actually have dark constituents that are associated with the electromagnetic spectrum, for example. And that might explain the glue that holds the electric and magnetic wave patterns in 90-degree juxtaposition or offset. There's a whole series of contemplations there that that are beyond the scope of this presentation, but the point is that even that is consistent with the emergence model and the approach here that we did. Gravitons we've already talked about. In the standard model of particle physics, there are the normal subatomic particles, but there's also a list of 100 or so virtual particles that have a longevity of picoseconds or some very short period of time measured in. Those kinds of particles are in a class in the emergence model called prions, and they have destructive resonances. They resonate to destruction, basically, and they do that on those time frames that are consistent with the standard model of particle physics. On the other hand, there are preons in particles like protons and neutrons that dampen quarks, and quarks don't usually exist in an unbound state. They only exist when they're bound, and because they need something to dampen the energy levels that they have, and the answer to that in the emergence model is preons. And if you look at the sum of the masses of preons relative to the sum of the parent particle, in this case either protons or neutrons, you'll find that that parent particle has a huge mass that's greater, hugely greater than the sum of the quark masses. And that margin, that delta mass, is the mass of the preons in the particle. That's what that mass is. That's what those are. Destructive resonance also explains matter-antimatter relationships relative to the symmetry in the configured particles. So the emergence model takes care of that. So if we have an isotropically smooth lattice of configured particles and we resonate them with a certain energy, the lattice is going to respond as opposed to the individual constructs within it, the constituent constructs in it. And it is that balance that explains phenomena like the Higgs mechanism. And it also explains that when the particles come up, why they generate the bosons that they do in the case of the Higgs or the other particles. And so it's consistent with that. The regression analysis across the analytical stack of the translation matrices then positions thermodynamics in context of action across the permutations of relative and respective configurations of architectures of mass interacting in a given event frame. And that is also a big aha moment. It's just every single time we tried to break the emergence model or the manner in which we went about investigating it, they reinforced our understanding of the laminate. The laminate only got stronger, and that's why we refer to it kind of that way. It's kind of like plywood. It's just a very strong approach to analytical rigor and discipline. Part 3 of the ahas from the analysis phase from our original systems review that absolutely gobsmacked me had to do with the WMAP data. And I have spent a considerable amount of time in the IT industry working with all kinds of stuff. And without getting into any kind of specifics, part of the point here is that there are cases where you might see codified into legislation a phrase that says natural people shall not. It's the natural people are precluded from a given action or behavior. If you see that codified into legislation, the implication there is that there's probably a computer somewhere that's doing exactly that, but it's not. No human is able to see what the computer is doing, but the computer can report a flag that says, hey, a condition exists. Maybe you should go look at something, and it doesn't provide any of the underlying detail, none of the rationale, none of the characteristics that might go along with natural people performing that behavior or that action. And there is a point here, is that those flags, those semaphores that get communicated, they are done so in an indirect manner that's compliant with the statute. Okay, that's one issue. But if we take that same idea of indirect communications and go back through the data that we have available to us already and say, are there any clues? Are there any flags that something may exist, for example, beyond our particle horizon? And the answer to that question is yes. There are. In the WMAP data, and I'll back up again, because about 20 years or so ago, I forget what the actual date is, there was a comet asteroid, Shoemaker-Levy 9, that had essentially 9 objects that were gravitationally locked in basically a line, and they all impacted Jupiter as Jupiter rotated. They kind of went in like machine gun bullets. And if we take that same idea and then go back and look at the WMAP data, and then we put that in the context of the Bang to Bang article that we wrote, what we find is that the WMAP data has statistical circles in it that's forcing those guys to scratch their heads. They don't know where those statistical circles came from. And in an M1 context, they make no sense. And they don't, because in the M1 frame of reference, the Big Bang occurred because of quantum fluctuations in finite regions of space. In the M5 incarnation, lens, however you want to think about it, it happened the way it's articulated in that Bang to Bang article. And then applying the Shoemaker-Levy 9 idea is that there weren't just two supermassive black holes, there was a multiple of them. The two that created the initial bang were followed up with subsequent ones that went through the mirth after the fact and created those statistical circles that we now find evident in the WMAP data. And so here again is another example where holistic insights provided by elegant reasonism in context of the emergence model are perfectly consistent with the litmus that we look to in the unified universe. And it's not the only one. We can look at Laniakea, the large superclusters, and that's perfectly consistent as well. It really kind of doesn't matter where we look. We've been unable to break the emergence model and the analytical rigor that's imposed by elegant reasonism. And, again, the philosophical 800-pound gorilla in the room is the question of where did the MVPs come from? We don't know. The question about other EIMs with a better answer, is a plausible thing to go pursue if that's what you want to go do. So that's another insight that we just absolutely did not expect. But when we did look at it, what we found was affinity with the unified universe. Part 4 of the ahas from the analysis phase came subsequent to our insight about the statistical circles in the WMAP data, because there's a subsequent implication of them that we did not expect, and they really did gobsmack me yet again one more time, because the WMAP data is an assessment of all of the signals that we can get that are inside our particle horizon, and the implication that there were these subsequent bodies that went through that mirth and went on mean that when we say the phrase the universe, that's an all-encompassing abstraction that the definition of underneath it means all that is. But the implication of those statistical circles means that what's inside our particle horizon is not all that is. That's just our part of it. That's our corner of the universe, the real, larger universe. It means that our unified universe is that real part of everything that is, but within our particle horizon. Because what lay beyond the particle horizon, for all intents, practical purposes, is something that entails an area that we will never know the answer to. Because the definition of a particle horizon is that it is the furthest point from which any signal can reach us. In the same manner that those flags and semaphores can be parsed from a confidential system or a classified system to alert people to a condition that might exist, those statistical circles in the WMAP data are flagging the same kind of signal to us, but it is an indirect signal. It is not a direct signal. This then also goes back against how old do we think the universe is, and how old is our unified universe. Those two things have different answers depending on how we reconcile z-factors. Z-factors today are measurements of the inflation of space-time, but if we normalize those back to Hubble's original assertions, and we go back through that inventory, which is work that we have not done yet. We've looked at some of it, but it needs a formal treatment to really assess the velocities and the sizes and the et cetera, to understand exactly how big the universe actually is, our part of the universe is, those velocities, etc. One of the things that was reconciled for us when we did these in our original system review was that there's a grand design spiral galaxy called BX442, and the issue with this is where we find that galaxy. It's very, very far away. It's so far away that I want to say it's, if memory serves, there's only like 500,000 years between Big Bang banged, and there's just not enough time for it to have formed, because a grand design spiral galaxy takes about 11.5 billion years to form, and given where BX442 is located, there's not enough time for it to have formed from when the Big Bang banged. That's called a concept compression issue. When we reconcile our universe in context of the Bang to Bang article, we find that the universe is unfathomably old, it's very ancient, it's very much large, and suddenly BX442 has plenty of time to have formed in the position that we find it today. And so we reconcile that issue also. And so it's again yet another example of an aha moment where we thought we were going to break the emergence model or elegant reasonism, and we failed because it reconciled it and said, no, if you just think about it this way, then it's perfectly consistent. And we were stunned. Also, another issue that stunned us is just using representational state transfer from the information sciences as an example. All these different linkages holistically coming together to form the laminate that strengthens not only the process and the emergence model and all the tools and things that we're using here. Just the fact that holistically all these different things are coming together is an aha moment in and of itself. And I'm at a loss of words to describe how I feel about all that and what the implications of all this are. But I do know that they represent an incredible R&D opportunity that we need to jump on. So let's talk about metrics in terms of how we measure effectiveness across the elegant reasonism process as they relate to the decision checkpoint flowchart. There are two kinds of metrics essentially in elegant reasonism, but metrics, the caution is that metrics employed in a standard manner will ultimately and likely fall prey to Langer epistemology errors. Metrics need to be viewed through the holistic lens of elegant reasonism, and when we do that, we find that there are two different kinds of metrics. One applies inside the encapsulation of a given EIM, and we can measure Six Sigma, we can measure quality, we can measure error rates, we can measure all those things inside that encapsulated model, that encapsulated interpretive model, the EIM. But then there's a different kind of metric that applies to the analytical layers down through the translation matrices. And some of those metrics apply exclusively to a particular analytical layer, and some of them are holistic across the analytical layer, all of the analytical layers as a holistic metric. And so the caution here is that we are critically situationally aware in our thinking as we apply the metric. And so be careful to make sure that we are mode shifting metrics as much as we are the data we are investigating. And that is the purpose of this chart on metric. And the metrics must be just as fully compliant relative to the EIMs to the realm of C's, as anything else in elegant reasonism, the data or the investigation. And we just need to make sure that we know where those lines are and that we don't cross them, and we're going through our decision checkpoint flowchart as much with the metrics as we are with the data and area of investigation meeting our objectives and our goals. Developing the treatise. So when we back up from our introduction to mode shifting and we begin to develop our treatise, we see that there are a few holistic insights. And mode shifting M1 to M5 reveals a myriad of insights spanning science. I would probably argue spanning philosophy as well. The list here is in no way comprehensive. It is representative of a few fairly profound implications, and that has to do with accomplishing unification in this exercise. But the dismantling of M1's limitations regarding the speed of light and the mode shifting that finds severance responsible for its constancy and architectures being responsible for the wave-particle duality resulting from the fundamental entanglement function limited by severance is interesting. And when we understand that rapidity becomes the predominant factor for velocity in M5, we then start looking at structure of architecture that allows those structures to exceed the severance of two individual MBPs, for example, that might otherwise disentangle. What we find in that holistic set of circumstances is that rapidity is responsible for quantum mechanical velocities in the context of discontinuous architectures of mass. When we observe that insight, we then realize that it is this function that is responsible for the velocities associated with quantum mechanics and quantum computing. It is the speed of entanglement that allows us to do what we've achieved so far in quantum computing and the structures that we fabricate to produce those systems. We also then begin to look at complex composite architectures of mass across all scales isotropically. And this means from the single MBP all the way to supermassive black holes and everything in between. When we look at those architectures, we need to look at those architectures to the edge of severance for that architecture. So if the architecture is such that it supports higher levels of severance, then it's going to take higher levels of energy to achieve that severance. So, for example, when we look at the redshifted factor of these supermassive black holes that are exiting our part of the universe, it supports that bang-to-bang article, and we see that they are retreating at excessive rapidities. And I would point out that rapidity in that cosmological sense is infinite. That it's one of the few infinites that survives what constitutes an infinite quantity. If we exceed the severance of that supermassive black hole system, that supermassive black hole is going to be rendered back to the mirth that created it in the first place. And in that case, we will have a big bag of MBPs that, due to their intrinsic nature, start the whole process all over again. The other point here is that everything real is a system or a system of systems governed by the intrinsic nature of MBPs, or most basic particles. The unified universe is unfathomably vast and exists well beyond our particle horizon, as we've already discussed. The statistical circles in the WMAP support a mode-shifted conclusion made in the Big Bang to Bang article. The unified universe is unfathomably ancient. Mode-shifting the estimates on the age of the universe may push it in potentially an order of magnitude older than we think it currently is. It may be even older than that. We just need to go through the inventories of data, do the math, and come to those conclusions. But that's going to require, everybody in the international community coming together to do that piece of work. We need to really understand those statistical circles in the WMAP data relative to what may be beyond our particle horizon and relative to what's going on inside our particle horizon as well. But that's, again, another set of R&D that the system that we have proposed to the National Science Foundation, a use to which it might be put. And so that remains to be done. If you want to help us, you can call the National Science Foundation and ask them to support our recommendation. The new class of astronomical phenomena, the mini bangs, we gave you some examples of those earlier in the presentation. We need to inventory those things, and we really need to distinguish those from supernovas. And there's a set of nucleosynthesis events that we need to collect and understand element production as a function of nucleosynthesis that occurs in a normal supernova versus these collision class objects. And it may be that the different energy signatures and the way that those run through the energy signature taxonomy matter in terms of, I don't matter as in terms of being important as opposed to matter as a thing of mass. So we just need to go through all of that and understand that better than it's currently documented. We need to really go through the Bang to Bang article, and other people can take what we've done and expand that envelope and maybe come to a little greater precision on what we've done. Everything we've done is so far is just one small teeny tiny step. Unification is a tapestry that is a great deal larger than any single discipline of science or philosophy. Everything seems to be unified. It now requires us to all come together and demand a comprehensive systems review and mode shift what it is we think we know across the body of science and all domains of discourse. Some of the overall surprises from elegant reasonism and mode shifting M1 and M5, the implications that everything real is subject to the fundamental entanglement function limited by severance was one surprise. Everything we could come up with falls prey to those two processes, and that includes black holes. We were thinking that once the black hole's created, it's a kind of forever thing. No, I'd never expect, with the exception of Stephen Hawking's demonstration ability to show that they evaporate, and that even that is a function of its size. But with the exception of that, of them evaporating, it was a huge surprise that they're subject to severance every bit as much as anything else is under the right conditions. If the somewhere else there's another supermassive black hole and the two vectors of these things cancel each other out, that is, the event frame for those coming together exceeds the severance of all the systems in the event frame, then those objects will be reduced to MBPs. The MBPs, as a result of that, will then be subject to their intrinsic nature, and they'll start the whole process all over again. The implications of our universes versus the universe was a huge surprise. We were not expecting that. Another implication was that it appears to us that, and I'm not going to get into how we came to this conclusion, but it appears to us that events across the solar system are consistent with everything we've talked about so far, and because of that, it looks like Mars and Venus may have once had oceans, and they've lost their oceans to space. And because that's true, there's no reason to suspect that Earth is not losing its ocean also. We obviously still have an ocean, and so the question then is, why do we still have an ocean? And the answer to that is that it's been replenished with comets. And so it's just another area that's consistent, and it's consistent with LE frequencies. And you can look that up in the paleontology record and see that seems to be the case. And even with the recent NEOs coming through the system, everything seems to line up to that conclusion. The other area is once you get to that bang-to-bang precipice, and you've been able to do that and explain that and rationalize it and justify it across the epistemology employed, you then must come up with linkages to everything else in the epistemology and human endeavor. And Suzanne K. Langer's body of work links symbology and philosophy all the way out to art appreciation. Ludwig von Misse's body of work links his treatise on human action, a treatise on economics. Benoit Mandelbrot's body of work, especially the fractal geometry of nature, has great affinity with M5 and M6. If we take the individual MBP as a fractal initiator, then the conclusion there is that the universe is actually a fractal. But it's consistent with knot theory given the intrinsic nature of MBPs. But that, again, is another area of R&D that we would like to prove. And there's a lot I'd like to say there that I just don't have time for right now. Affinities exist for astromineralogy, cosmochemistry, supernova nucleosynthesis. All these areas have great affinity for what we've already gone through and what we've tested. All of the different states of matter, including what happens when we supercool things, real objects. The holistic affinity that elegant reasonism has for finding truth as a function of the unified universe itself was very surprising, and we did not expect to do that. That was not our original objective or goal. We just kind of stubbed our toe on it when we did it. And so I'm happy that it all worked out. I'm happy that we found what we found. I wish I could have found ways to articulate all this faster and better so that people can come to understand what it is we've done a little easier maybe. So when we look at the development of our treatise, and we've now backed up away from the recognition phase, the illumination phase, and the analytical phase, we find that the process has a purpose of eliminating Langer epistemology errors to the degree that we can do that, and the implications that they cause. We eliminate concept compression issues, things from the Big Bang must have enough time in order to develop. Something that should not be where it is when we find it must be reconciled. Another example is when we reconcile the supernova with the collision class elements, and we look at the Kepler data, for example. There's a short list in the Kepler data that appears, when we looked at it years ago now, it appeared that some set of those may be working on Dyson spheres, and that too is consistent with everything that we've looked at here. And because of that, because of the nucleosynthesis issues, because of the supernova issues, and because of the many other areas, that essentially reconciles the Drake equation with the Fermi paradox. And we find that life might be out there all over the place. It's just that it's incredibly difficult to communicate. And I hate to say this because I'm a big Star Trek fan, but the warp speed stuff and the hyperspace stuff is essentially foo-foo dust. That's not going to work. The Alcubierre drives and those kinds of constructs, because we can mode shift those concepts as well. And what we find is that if you look at a palisite meteorite, you will see, if you're holding one of those or a piece of one of those in your hand, you may be holding a piece of a supernova from a long way away. But that also means that those big, rather large objects are between here and there. And if you are going really fast, you're going to run into them. And that may make travel between those places problematic. And so we just need to rethink all of that, and then look at managed severance fields and what we can do with that. But in any case, the arbiter becomes the unified universe, and it is always held distinct and litmus. The traditional epistemologies are integral, but they are statistically weighted relative to and respective of their ability to reflect the unified universe. And so if you have an EIM and it dovetails, and you can do grand and glorious things, and you can create all kinds of interesting technologies and from that EIM, that's all well and good. But if it does not accomplish unification, then there's a piece of the puzzle that you're missing. And the question then is, what value does the missing piece have to your stakeholders, your shareholders, and to your business and your supply chains and your value chains? The degree that ISO 9001 quality management system standards matter is important, and Six Sigma and Baldrige and the other quality systems that you might employ against any given process, they're important, but they also have to be mode shifted. And when we do, we find that there's those two different kinds. There's the kinds that you apply inside of an EIM because they're encapsulated every bit as much as the data and the concepts and constructs of the EIM are. And then there are the holistic quality metrics that apply across the translation matrices analytical stack. And when we look at that from that perspective, we must then also consider root cause analysis isotropically across the analytical stack and across scales of an EIM, and how that all comes back together. And we need to understand where the encapsulation boundaries are, and again, the enumeration, iteration, and inventory practices and metrics associated with those things as well. All of these things holistically matter to the development of a treatise. And it is for these reasons that I tend to think it's easier to develop a treatise that is fully compliant in manuscript form than it is in an actual three-dimensional matrix that we might use in mathematics. Relative to the overall ahas, I'm just going to say that nobody's more surprised at all of this than me. I'm stunned. I had no idea that this was all going to come together this way. We just did it, and we kept pushing, and we kept engaging people more in terms of trying to get confirmation and increase situational awareness on the insights that we were seeing than anything else. But it is what it is. The material is getting into the website as fast as we can put it there. We're a small organization. We need lots of help. These presentations, these PDF charts will help explain things to many people. I hope these videos on our the SolREI Studios channels are helping, because the quest for unification may be over, but the real work is ahead of us, and the real work is mode shifting what it is we think we know into alignment with the unified universe. The tapestry of unification is by definition inclusive of everything, and it's not this area or that area, and it requires us to use the best we can. We have to employ QMS system standards, quality management system standards, to the degree that we can to reduce and eliminate errors. We have to eliminate Langer epistemology errors. And Suzanne K. Langer so poignantly pointed out way back in 1948 that with these new insights comes a whole new world of questions that we must ask and answer. And that work lay ahead of us. It's not behind us. In summary, the quest for unification may be over, but the work is still in front of us. Not only are we not the center of our solar system, we're not the center of our galaxy, nor are we the center of our universe. We don't even know where the center of the universe is, or where we are relative to it, and we never will. It's beyond our particle horizon. Life is likely replete across all of those configurations, and as the old language says, we are in that image. Everything real is. We are a part of that intrinsically, so we cannot escape it, nor it of us. And so R&D is associated with all of this is probably the single largest computing opportunity humanity will ever have, and it revolves around the implications concerning the architectures of mass, which is why we made the proposal to the National Science Foundation that we did. There's a lot of other implications of this to our biosphere, and it means that we need to hold our biosphere precious. We need to do that with great import. We have a strategy that we've been sending to the White House since 2006, I think, and it's One Pilgrim's Wish for Earth, and it is on Amazon and available if you want to look at it. The executive implications: when the USPTO published Elegant Reasonism, the proverbial genie was released from its bottle, never to return. There's nothing anybody can do to ever put that genie back in that bottle again. And as Sir Arthur Conan Doyle might say, the game is now afoot, and nothing anybody can do can stop it. Not government, not business leaders. And so There are all kinds of metaphors. We've discussed some of those in Unification's Wake, Part 5, the business implications. I would encourage you to review that video or that set of charts. They're in the user library and the info tab on solrei.co. Elegant Reasonism is an epistemology supported by an analytical framework which seeks truth as a function of the unified universe as a philosophical predicate priority consideration entering science. It's very powerful. The more effectively you can wield it, the more we all need to consider the ethics associated with being able to do so. And so I would ask everybody to take that into consideration and do what you think is the right thing to do. We need to understand the implications of Langer epistemology error and that they represent a gate and they ensnare the innocent with logically correct empirical abstractions which preclude recognizing the holistic tapestry that is unification. And you don't want to beat people over the head with that. You want to help them to understand so that they can see past the gate. Some people are not ready to go through that gate, and people need to go through the gate if they want to go through the gate. And I think that that's important, and I think that that's an important consideration as we help each other the best way we know how. With that, that's the introduction to mode shifting, M1 and M5. I hope that this presentation has been useful. And again, I'll just say in closing that I know a lot of people think that we probably should have come out with this presentation first, but the context of the other presentations and the other presentations being able to help people understand what the context was is important. So I know that this has been a long presentation and I appreciate your time. Please click that subscribe and notification bell. We have a lot more presentations to come, and I promise that they will start to be very, very short.